I'm going to show you how to add authorization to an existing application using row-level security policies. We're going to be extending this email client application, originally built by Lee Robertson at Vercel, and we're going to be going pretty deep on the Postgres side. So we're going to be learning about functions, triggers, security definers on roles, and setting up one-to-one relationships across tables in different schemas. If you haven't been following along with the series, I'll leave a link to the full playlist in the description, but don't worry, this video can be watched without any context of what we've done so far, so long as you understand what an email client looks like. And even if you don't, this is it. We have a panel of folders on the left, a list of emails in those folders in the middle, and then if we click one of these emails, we see the content of the selected email on the right. We can send a new email or delete an existing one, and we've also added the ability to log in with GitHub. So if I log out, we'll see this sign in with GitHub page, and so if we try to go back to our landing page, you'll see we're automatically redirected to this login page, so we can't actually access our emails unless we sign in with GitHub. But we're not doing any filtering on these emails displayed. If we have a look at the Supabase dashboard, and then under the table editor and emails, we'll see the IDs for our sender and our recipient are 1s and 2s and 3s and all the way up to 10. And if we have a look at our users table, we don't actually have a row for our Jon user. And if we go over to authentication and then users, we'll see there's only one user, which is Jon, who used the provider GitHub. So we have two separate users tables. We have the ones that have sent and received emails, and then we have the ones who have signed in with GitHub. And if we head over to database and then schema visualizer, we can see this very cool entity relationship diagram of all of our tables and their relationships to each other. I can just zoom out slightly so we can see all of it. So the ID on our users table has a relationship to the sender ID and the recipient ID in emails, and also a relationship to the user ID in our user folders table. So this is everything in the public schema, or the tables we've created for our application, but there are a collection of other schemas being managed either by Supabase or any extensions that we have enabled. And if we have a look at the auth schema, this is all the complicated stuff Supabase uses to keep a track of our sessions and also our users. So this is the users table where our users are created when they sign in with GitHub. And then back over in our public schema, we have our users table that's linked to our emails and the rest of our application. So we want to set up a relationship across these schemas to link our two users tables. But the types for our IDs do not match. Our public users ID is an int4, and in our auth schema, our users table's ID is a UUID. And you can only set up foreign key relationships between two columns that have the same type. So in order to link our public schema's users table to our auth schema's users table, we're going to create a new column for our public user that's of type UUID. So let's head over to the table editor, and then for our users table, we want to scroll across to the end and click this plus to add a new column. The name is going to be Supabase_ID. We're going to click here to add a foreign key relation to the auth schema. The table we want to reference is users, and the column we want to reference in the auth.users table is the ID. If we scroll down, we can also set up the behavior for what we want to do if the row is updated in the auth.users table. So in this case, we don't want to do anything. So we want it to raise an error if it breaks something that's needed for that foreign key relationship. So if the ID is changed, which shouldn't ever happen, we want to get an error. However, if the auth.user is entirely removed, we could go with no action and raise an error, or we could do cascade, meaning if a user is deleted from the auth.users table, we want to cascade those deletes to the public users table. So they would also be deleted. But then we'd need to cascade the deletes to all of their emails and all of the other tables where they're a recipient or a sender. And so it probably doesn't make sense for us to just nuke all of their existence from the entire database. Instead, we're just going to set this to null. So if the user is deleted from the auth.users table, nothing happens to our public user, which is linked to all of the data of our application. It just removes that link to the auth.users table. So our public user no longer has an auth.user. And then we can click save to set up that relationship. And if we scroll down a little bit, we can see the type has correctly been set to UUID, which is the type of our ID in the auth.users table. The default value is going to be null, so we need to make sure that allow nullable is enabled. We also want this column to be unique. So this sets up a one-to-one relationship between our public schema's users table and our auth schema's users table. So there can only be one user in the public schema that references a particular user in the auth schema. So let's click save to create that new column. And now anytime a new user is created in the auth schemas users table, so when a new user signs into our Next.js application using GitHub, a row will automatically be added to this table. And when that happens, we want to automatically create a new user in our public schemas users table and link them up using this Supabase ID column. And we can do exactly that with a trigger function. So let's head over to database and then functions and then create a new function. The name of this one can be handle public user. The schema will be public. The return type of this one will be a trigger. We don't need any arguments. And then in the definition of our function, we need a begin and an end. So you can learn all about begin and end and Postgres functions and transactions in a video we did earlier in this series. Again, link to that playlist in the description. So inside the body of our function, we want to insert a new row into the public.users table, and we just want to set the Supabase underscore ID column and the user's email. So the values will be new.id. So this new variable is special to trigger functions and represents the entire row that's just been created in the auth.users table. So the new.id is the ID of the user who's just signed in with GitHub and been automatically added in the auth.users table. So to access their email, we can say new.raw underscore user underscore meta underscore data, which is a big JSON blob of all the information we get back from GitHub about this user. So we can access the email property using this dash greater than symbol, and then the string of the property in that big JSON blob. So in this case, that's email, and then we'll add a semicolon at the end and make sure we return that new variable. Now this will insert a new user into the public schema, but one may already exist if they've been the recipient of an existing email. This is tricky. I love it. So this means we need to use an upsert action, which first attempts to insert a new user, but if one already exists, it will instead update its Supabase underscore ID column to link it to that new user in the auth schema. The way we do upserts in Postgres is we first try to insert that new user with those values, and then on conflict of the email column, so a user already exists in our public users table with that specific email. So in that case, we want to do an update and set the Supabase underscore ID column to equal our new.id. And the last thing we need to do is click show advanced settings and then change our type of security from security invoker, which we'll call it on behalf of our user. So RLS, which we'll look at soon, will be enforced. We instead want to change this to security definer, which executes the function with our current level of privileges, which is the Postgres role, which we use for our Supabase dashboard. Again, we'll go into roles later, but basically if we're doing something on behalf of the user, then we want security invoker. But because this is a system action that's to do with the integrity of our database, we want to do security definer. So let's click confirm to create that function. And now we want to call that function when a new user is added to the auth.users table. So let's head over to the SQL editor and we can get Supabase AI to help us out. So let's say create a trigger that calls the handle underscore public underscore user function when a row is inserted into the auth.users table. And let's see what it comes up with. That looks pretty good. Let's accept that change. So we're creating a trigger called this. We probably don't want that to be the same name as our function. So maybe we'll call it on auth user created. So after that insert takes place on the auth.users table, for each row that's affected by the statement, so for each user added to the auth.users table, we want to execute the function handle public user. So let's click run to create that trigger and we see success, no rows returned. So everything's all good. So to test this out, we can go back to our application and then sign out our user. And then in the Supabase dashboard, go to authentication and then under users, we want to find our Jon user and click these three dots and say delete user. This is just a warning telling us that this is permanent. And so let's click delete. Now, if we go back to our application and sign in with GitHub again, we'll see that authentication process was successful. We can see our Jon user there. If we go back to the Supabase dashboard and then reload our users, we'll see that Jon user is back and has signed in with GitHub. And if we go over to the table editor and look at the users table, we can see our user has automatically been created and linked to the auth.users table with this Supabase ID column. But back over in our application, this still doesn't change the emails that our Jon user is able to see. So let's make it so that our Jon user is only able to see emails that he either sent or received. So let's head back over to authentication and then policies, and then we want to enable RLS or row level security for the emails table. So let's click enable RLS and confirm, and we'll see this one's now green instead of all this yellowy orange caution stuff. So we're on the right track. Now by default, RLS automatically denies all requests to the table. So no one can select, insert, update, or delete any of our emails. So if we go back to our application, we can still see those emails. So let's refresh and we can still see those emails. Wait, what? They're all still there. Is RLS not working? RLS is definitely enabled on the emails table, and we haven't written any policies to enable any of those actions, so it should definitely be denying requests to select data from the emails table, but our application isn't actually using just the emails table. We're using this view for the emails with folder and users, so this joins together all of the data about the email, and then a big JSON blob for the recipient and the sender, and it also gives us the folder that they belong to. And by default, views bypass RLS. But we can fix this pretty easily. We can toggle between the data that's returned by our view and the definition, which gives us the SQL required to reconstruct that table from scratch. And we can open this one up directly in the SQL editor. And now we can make some changes by saying create or replace a view called emails with folder and users. And then we can add a with clause to set security underscore invoker equal to true. Now, if we run this statement, we see success, no rows returned. And if we go back to our application and refresh, we'll see our Jon user is no longer able to see any emails because the view that selects this data is now honoring RLS. But we can see the count for each of our folders is still bypassing RLS. And if we go back to the Supabase dashboard and then the table editor, we can see that's this view for folders with email count. And we can do the same thing by going over to the definition and opening it in the SQL editor. And again, saying create or replace the view called public.folders with email count. And we can add our with clause to say we want to set security underscore invoker to equal true. And then if we run this one, we see success, no rows returned. And if we go back to our application and refresh, these folders are still getting that count for the number of all of the emails that exist within that folder for every user. And this is because if we have a look at our view, it's using the folders and the email folders tables, both of which still don't have RLS enabled. So we can see folders, email folders. So let's start by enabling RLS for the email underscore folders table. This is what's being used by our count. And now if we go back to our application and refresh, we can see no more emails. And this is exactly what we want. This doesn't mean it's broken, it means it's working. Remember, RLS denies all select, insert, update, or delete requests. So if we want to enable one of those, we just need to write a policy. So back over in the Supabase dashboard under authentication and policies, let's start with our emails table and write a new policy. There are some templates available to get you started, or you can use the Supabase AI assistant to write these for you, but we're going to create this one from scratch so that we can talk through exactly what's going on. So the name of our policy is going to be users can read their emails. So because this is about reading, we're going to enable the select action. We're going to leave the target roles as the default, which just applies to everyone. And then for our using expression, we need to provide a statement that either evaluates to true or false. If it evaluates to true, then the user will be able to select that email. And if it evaluates to false, then RLS will just continue denying it. So if we set this to true and then scroll down and click review, this will show us the SQL that's been generated from each of those form fields. And then if we click save policy, it will run it against our Postgres database. So we can confirm that this policy is working by going back over to our application and refreshing, and we don't see anything. But if we go back to look at our view for emails with folder and users, and we can just look at the definition and see that it's using this email folders table, which also has RLS enabled. So let's go back to authentication and then policies. And for our email folders, let's write a new policy. Again, we'll do this one from scratch. This will be users can select email folders. We'll enable the select action, leave the default role as public, and then put true as the using expression. Now, if we scroll down and review and then save policy, now when we go back to our application and refresh, we see our emails are back. But our Jon user has just been created, so they aren't the sender or receiver of any of these emails. And we don't want everyone to be able to see everyone else's emails. That's not very secure. So instead of just returning true, we want to check that the recipient underscore ID column is equal to our current user. And we can get our current user with a special Supabase function called auth.uid. But the problem is this will return us a UUID, and this is the integer ID that's used by our public schema. So we're going to use a subquery here to say the recipient underscore ID is in the result set that comes back from selecting the ID from the public.users table, where the Supabase underscore ID is equal to the result of that auth.uid function. So we know our Supabase user, we know the ID of our public user, and so this will kind of glue those two together. And we also want the emails where they are the sender, so we can do the same thing and say or sender underscore ID is in, and then copy and paste that same subquery. And now if we click review, we'll see the SQL that's been generated to alter our policy and save policy to run that SQL against our database. And now if we go back to our application and refresh, we'll see no emails because our Jon user hasn't received or sent any emails. So we can go back over to the table editor and go to emails and change the sender for this first email to be our Jon user, and then change the recipient of this one to also be our Jon user. Now, when we go back to our application and refresh, we see one email in our inbox, which is weird because it's sent both from me to me, but that's fine. And then if we look in our sent emails, we see one email that's been sent. So we can see our numbers are still off for each of these folders. And that's because in our RLS policy, so over in authentication and then policies, our select policy on our email folders table is still just using the expression true. So since we always want the number of emails in that folder to match the number of emails we can select from that folder, we can actually use this little trick to enforce policies from another table. So we can say select star from emails where email underscore ID matches the emails table's ID. And now since the RLS policies from the emails table are going to be enforced on this select statement, our user is only going to get back records that the policies on the emails table allows them to. So another little efficiency tip here is rather than actually selecting those columns, we can just select the number 1, which represents true, and then we can wrap this in an exist statement. If we get back the value true from this select statement, then this entire policy will return true. Otherwise, it will return false. Again, because this requires a user to be authenticated, we can set it to the authenticated role to ensure it only runs for users who are signed in. Now we can click review to see the SQL for our policy and save policy to run it. And now if we go back to our application and refresh, we'll see we only have that one email in our inbox, which is this one, and that one email in our sent folder, which is this one. Wow, that was a little bit complex if you're new to RLS. If it didn't quite click, just take the video back and watch it again. You can do that as many times as you want. Okay, so our users are able to select the emails that they are the sender or recipient of. But what if they try to delete an email? It looks like it's no longer selected here, but it still exists here, and it still exists here. So I don't think it's actually gone. Let's try refreshing. Yep, still there, and we can click it and still see its contents. So delete is not working. And you know why. It's RLS. We wrote a select policy, but if we want to enable the delete action, we need to write a policy for it. So back over in the Supabase dashboard, on our emails table, we want to create a new policy. Again, we'll do this one from scratch. The name is going to be user can delete their emails. It's going to enable the delete action. The target roles is going to be set to authenticated. And then for our using expression, it probably only makes sense for a user to be able to delete emails that they sent rather than received. So we want to check that the sender underscore ID is in this subquery where we select the ID from the public.users table where the Supabase underscore ID is equal to the auth.uid function. So let's scroll down, click review, and then save policy. And if we go back to our application and try to delete this email in our inbox, it's not going to work because remember, we are the recipient. But if we go to our sent emails and try to delete this one, let's click that little delete button. Again, it's no longer selected, but it's still here in our list. So what's going on here? Well, we've written a delete policy for the emails table. And if we have a look in the table editor for our email folders table, our email ID column has a foreign key relationship to our emails ID. And on delete, it's cascading. So whenever we delete a row from the emails table, it's going to cascade down to our email folders table. So we can go here to get back to our policies and then just remove this search term to see all of our tables. So if we have a policy for delete on our emails table, we also need a delete policy on our email folders table. So let's create a new policy. We'll do this one from scratch. It's going to enable delete for sender. It's going to enable the delete action. We're going to select the authenticated role. And then for our using expression, we're going to select star from the emails table where the email_ID column matches our emails.id. So this will give us back the email we're trying to delete. We then want to select the sender_ID. So again, this is the integer ID from our public users table. So if we want to match that against our currently signed in user, we need to get their Supabase ID. So we'll come back to this one and say select Supabase_ID from the public.users table where the ID is in this subquery, which will be this select. So we have the sender ID of the email. We're then looking up that ID in the public.users table and then just pulling out the Supabase_ID column. So lastly, we just want to check, is the result of the auth.uid function in another subquery, which is going to be this whole select. So we can move this one inside this one and we can fix up our indentation. And now we're only enabling delete for the sender of that email. So let's scroll down, click review and save policy. And now when we go back to our application and select one of our emails in the sent folder and attempt to delete it, we can see it's disappeared from our selected email. It's also disappeared from our list and our email folders. Awesome. We can select and we can delete emails. But what about sending a new one? Well, we're about to run into exactly the same problem with RLS. So we need a new policy for insert. Just to make this a little easier, we can edit our delete policy and copy our expression and then create a new policy again from scratch. This one will be users can insert their own emails. This will enable the insert action. The target role can be set to authenticated. And then for our with check expression, we want to check the same as our delete policy. So if the sender of the email is the same user as our currently signed in user, then we want to allow them to insert that row because it wouldn't make sense for them to send an email with someone else set as the sender. Let's review and save this policy, and we can do the same for our email folders table. So let's edit our delete policy, copy this same expression, then create a new policy from scratch that's going to allow user to insert email into folder. It's going to enable the insert action. The target role will be authenticated, and then our with check expression will be the same as our delete policy. So again, we're walking back the relationship tree from our email folders table where we know the email ID that the user is currently trying to insert. We then work our way back up to the Supabase ID for that user and check if that's the user who's currently signed in. Let's click review and save policy. And one more thing before we can actually send our email, we need to go over to database and then functions. And then for our send email function, we want to click these three dots and edit our function. And if we scroll down, we can see the definition of our function and where we're inserting a new email. You can see we're setting the sender ID column to the static value 1. And that's because in the initial template from Lee, we didn't have authentication yet. And so we could declare another variable like we did earlier to hold our sender's ID. But since we're super comfortable with subqueries, we can do this inline by selecting the ID from the users table where the Supabase_ID column matches the result of our auth.uid function. So again, we know our Supabase ID, but we want to look up our integer ID from the public schemas users table. So just to be more clear, we could prepend this with public.users, and then this integer ID is what we want to insert as the sender ID column on the new email. And so let's click confirm to update our send email function, and then back over in our application, we can send a new email to a user who doesn't exist in our application yet. So we could say Jon@supabase.io. The subject can be does this work, and the body can be I sure hope so. And when we click send, we'll see our sent folder now has 2 items, one of which is our Jon user, and because we are the sender, we can delete this one and it disappears from our emails and also our number of sent emails. And this is only just scratching the surface of why RLS is awesome and how powerful it can be to implement authorization rules in the database itself. If you want to go deeper with RLS, I recommend you check out this video right here. We go through a bit more theory on RLS and slowly work up to a similar example of enforcing RLS policies from other tables. But until next time, keep building cool stuff.